Hi, hello. Hope you have been enjoying all the lessons through my video lectures. And so far, we have understood the basics about quality, the basics about lean, basics about Six Sigma. I'm sure by now you have gained the absolute clarity on the term quality. And not only that, you also have understood about process improvement approach, how important it is to improve the process if we are really interested in improving the results. And we also had a session on origin of lean. Lean evolved from the company Toyota. And similarly, we also had a session to understand the history of Six Sigma and the success stories of Motorola, ABB, General Electric, and other companies. And we also learned about the various Six Sigma belt levels, which are very essential for successful implementation of Six Sigma in any organization, and the kind of infrastructure that is required for the deployment of Six Sigma, and all that we have discussed. And we also thoroughly understood the DMAC methodology, which Six Sigma requires for solving the quality problems. So, which means we have laid a proper foundation to understand the deeper meaning of Six Sigma. So, the upcoming videos will introduce you to the world of statistics. The basic statistical measures called the average and standard deviation. What is the meaning of average and standard deviation, and how it is connected to the central tendency in your business process and the deviation in your business process, and all that I'm going to slowly introduce, and that too with very simple and real life examples. And I will also help you understand the important terms, specification limits and control limits. The specification limits are generally provided by the customer, and control limits are decided by the way your process is operating. And I will also introduce you to the concept of normal distribution. You will thoroughly understand the important properties of normal distribution. If you gain all these basics, you will definitely be able to understand the exact meaning of Six Sigma. The very, very important question, which all of you are deeply interested in understanding, is what is exactly Six Sigma and how Six Sigma is different from other processes. Suppose if you have a Three Sigma process and also a Six Sigma process, what it means and what's the exact difference. And all these things you are going to clearly understand in the upcoming videos. Enjoy all my upcoming lessons. Thank you. So this is going to be a session on understanding what is exactly Six Sigma, right? And we will understand the basic statistics, the meaning of the statistical terms, average and standard deviation. And we will also recap our understanding on specification limits and control limits. Any product, any service, any business, right? Customer will always specify his requirement. Customer will tell his tolerable limits. We are going to call it as specification limits, right? And similarly, any process will operate between his extreme outputs, right? Any process will operate between the extreme outputs. Maybe the extreme on the right, extreme on the left, or you can call them as the worst outputs, right? And we are going to call it as process limits or process control limits, and then the understanding on the Sigma level. The statistics required to understand Six Sigma, the difference between specification limits and control limits, and the difference between various Sigma levels, 3 Sigma, 4 Sigma, 5 Sigma, or 6 Sigma. So in the process, you will clearly understand the difference between Sigma and Sigma level. Sigma is a statistical term called standard deviation. How much deviated you are from the center value. That's called a deviation. And standard deviation is represented by the Greek letter sigma. And then Sigma level, a measure of process capability. And then what will be the benefit of having a higher Sigma level to organizations and everyone. So this is what we are going to learn in this session. And now I'm showing my slide, a ring of fire, right? If I ask all of you to jump inside the ring of fire, I'm sure you will find it difficult to execute it. But if you have to jump, probably all of you will try to jump through the center. Am I correct? You all will try to jump through the center. For the simple reason that center is the safest point in this exercise. Center is the safest point in this exercise because center is the point which is away from the border. I mean, away from the ring in the border, because the outer ring has fire in it. If you have to jump inside the ring of fire, you don't prefer to jump here or you don't prefer to jump here because all these points are near to the fire. So which is the point which is safest? The center. This is how you should run any business also. If your customer says don't cross this point, don't try to produce products, don't try to offer services close to the point beyond which the customer would reject your product, isn't it? So these points, the point beyond which customer will start disliking your product is called specification limit. My point now is don't try to produce products near the specification. Beyond the specification, customer will reject. Near the specification, the risk will be too high, right? So try to come away from the specification. In this example, center is the point which is far away from the fire. So this is called central tendency. This is called central tendency. So where are we trying to operate our process? Where are we trying to produce our product? Where are we trying to jump? We will understand by knowing the central tendency of the process, right? So central tendency can be measured statistically using by three methods. Either you measure the mean, or you measure the median, or you find out the mode. Mean, median, and mode. All the three will help you to understand the central tendency of your process. Now, what are we targeting here? We are targeting here to jump through the center of the ring. And now, after executing several jumps, if you have data, calculate the central tendency using the data. If the calculated central tendency and the targeted point, which is the center here, both are same, that means you are executing your jumping activity perfectly. You wanted to jump through a point having a lower risk, and you are actually doing it. How do you know? I calculated one of the central tendency, maybe the mean, and then I checked the target, and mean and target are almost same, and that means you are executing your plan very well as far as the jumping is concerned. See here, jumping continuously through the center might be a difficult process, similar to producing several thousand products with the same dimension. This is what all of us mostly do in any business, right? So producing more in number is generally a difficult job. That's why customer gives a tolerance. Customer will give a tolerance, target plus or minus some value. Similarly here, the small point I enlarged into a circle. If you can jump repeatedly inside the circle, it means you are consistently jumping well. You are consistently safe, isn't it? That is the meaning. So your consistency is measured by knowing your position from the center. If every time your position from the center is small, that means you are very consistent. Suppose if you jump outside of the white color circle, let's say you are jumping in the yellow color circle. Now what do you understand? Your risk of being hit by the temperature is slightly increased. Hope all of you agree with me, isn't it? Now you have come close to the fire. The temperature will start feeling. Why your risk has increased? Because you have moved away from the center. Every time you produce a product, by any amount away from the target, you need to understand your risk is increasing. Risk of producing a defective item is increasing. Suppose if you go beyond, for example, now you have come to the orange area. Now what happened? You have moved far away from the center, right? You have moved far away from the center. Now your risk is really high. your skin, will definitely, start, your skin will start burning because you are now very close to the temperature. So what do we understand? The central tendency should be on the target. And then every point or every jump we make should be always close to the target. If it is not close to the target, you move away from the target. That is what is called deviation. So there are two things we understood here. One is central tendency. Another one is deviation. The central tendency should be on the target and deviation should be minimum. So how do I measure the central tendency? How do I measure the, what do we call the deviation or the variation? So central tendency can be measured using three measures. One is mean, another one is median, and another one is mode. And the variation you can measure using three parameters. One is range, another one is standard deviation, another one is variance, right? So range means largest value minus smallest value. Standard deviation is deviation from the target or deviation from the center. Every point will be away from the center by a distance. That's called a deviation. On an average, how much is the deviation for a set of number? That is called standard deviation. You square the standard deviation, it becomes variance. So standard deviation is represented by the Greek letter sigma, and so variance is sigma square. Mean means average. You add all the number, divide by the number of numbers, you get mean. Median, you arrange the number in ascending order or descending order and find out the number that is there in the center, and that is median. And find out the most frequently occurred number, that is your mode. So any one of these measure will reflect the central tendency in your process. The goal should be, central tendency should be on the target. And similarly, range, standard deviation, variance, any one of these will definitely reflect the spread in your process. The spread means the lowest and the highest. What is the distance between the lowest and the highest? That is the spread. You can understand the spread using range, standard deviation, or variance. Our goal is we want a lower spread, right? That means all these things should be low because all of them directly measure the risk. I hope all of you understood the meaning of mean, median, mode, the central tendencies, and range, standard deviation, and variance, the measures of variation or spread. And now let me check whether you have understood correctly or not. Now there are certain numbers here. How many numbers are there? 2, 4, 6, 7 numbers are there. I want all of you to calculate the average here. What is the average? You add all the number, divide by 7. I'm sure all of you will get 3. 3 is the average here. You can check. You can add, divide by 7, and you will get 3. So mean is 3. So if you continue running this process, your output is expected to be around 3. That is the meaning of average. The output is expected to be around the 3. And this conclusion on the average will hold sound if the spread of the process is small. Look at the spread. Lower value is 1, higher value is 5. So how much is the spread now? Range is 5 minus 1, 4 units. Since the range is found to be higher, the conclusion you have made earlier comes with the risk. There will be a lot of uncertainty. The measures of variation will increase the amount of uncertainty in your decision made on the average, right? So here very clearly the uncertainty is more because the range is high. If the range is high, standard deviation will also be high, variance will also be high, right? So we understood the mean, we understood the range. Similarly, median, if you want to understand, I have already the numbers are in ascending order. Now, what is the number that you see in the center? 3. So median is also 3, mean also 3, median also 3. Let us think about mode. What do we mean by mode? The most frequently occurred event or occurred number. In this case, 3 occurred 3 times. So which is the mode here? 3 is the mode. And here we understand mean is equal to median and is equal to mode. So this is one property generally a normally distributed curve will exhibit. In any normally distributed curve, mean will be equal to median and that will be equal to mode. Hope all of you understand the simple statistics here. You have a parking area. The parking area width is capital D. And you have got 3 cars. One car is bigger. The other car is half the size of the parking area. And now, if I park my bigger car, what will happen? My car cannot enter. If I still try to park my car, what will happen? My car will definitely get damaged. And this is an unpreferred scenario, right? Coming to the second, my car size is almost equal to the size of the parking area. I can park the car, but I have to be very, very careful. I have to be extremely careful. If I make any mistake while driving, I mean, when I have to park this kind of car, I should park my car exactly driving through the center of the parking area. Then only my car will get parked safely. If I drift from the center even by a small amount, then my car will get damaged, either to the right or to the left, right? So this process looks good. However, I can't rely on this process because it can't even tolerate a small deviation from the center, isn't it? So that's the second case. And coming to the third case, car is much smaller. I can park this car comfortably inside without any difficulty, and I can park it repeatedly, even if I drift by a small amount from the center, and then also my car will be safe because I have some additional tolerance, additional cushion on both sides. My car is not going to hit the walls of the parking area, easily because there is an additional gap here. So running your business process in this manner will make your process highly capable. Here, you are able to park the car. Your process looks capable, but even a small mistake, your process cannot tolerate. But here, the car size is only half of the parking area's width. That means I have made my process doubly capable, right? This is what you need to maintain. This is how you need to run your business process also with respect to any process. With respect to any process, customer will have certain requirements, certain specifications. If you go beyond the spec, customer will reject your product. Here, the specifications are represented by the walls of the parking area. So on the right side wall, this is called upper specification limit. This is called upper specification limit. Similarly, the left side wall is called the lower specification limit. In any case, you should not touch or cross the specification limit. If you touch your car on the wall, there will be scratches. If you try to go beyond the wall, there will be bigger damages, right? Same way, if you produce product beyond the spec, it will get rejected. Customer is not going to pay for your work, isn't it? So it is always a good idea to stay around the target. Listen to Takuchi's philosophy. What was Jenichi Takuchi said? He said, variation is a loss. So what is variation? Any deviation from the center is variation. So don't deviate from the center. Always drive the car through the center. Don't think that you have a cushion here. You have a cushion, but still stick to driving the car through the center. So keeping an eye on the central tendency and ensuring that central tendency always stays on the target is a great idea. And your conclusion on the central tendency will definitely hold good in real time if the associated variation is less, right? And this is what you need to understand. Hope all of you understand the logic of explaining this slide, right? So here the car size, car is your business process. The parking area, or I can say car is the process tolerance. And the parking area size is the customer tolerance. Customer tolerance are always represented by the specification limits. On one side it is upper specification limit. On other side it is lower specification limit. And car size will represent the process limit. On right side it is upper control limit. On left side it is lower control limit. So we will use all these terminologies as we continue with the discussion. And now I have another example for you, interesting example. Imagine you are a pilot and you are going to fly this Boeing or Airbus. Your goal now is you have to land this aircraft on the runway. You have to land this aircraft on the runway. And now I want to understand about your capability to land the aircraft safely in the runway, right? So I'm asking you to land continuously, and you have been landing. All the landing points on the runway are marked here. All the landing points on the runway are marked here. And you could see all the landing points are around the center line in the runway. It is simply because as a pilot, you wanted to land your flight around the center only. This is the line you have targeted for landing. You have not targeted this line, or you have not targeted this line. You have targeted this line only. Because you targeted this, all your landings are around this. This is what you will understand by measuring the central tendency from any business process. You collect data from the process, calculate the central tendency. Now you will know what is that your process is targeting to produce. What is that your process is targeting is to produce. If what the process is targeting to produce and your customer target are same, it will create a healthy scenario. And in my opinion, right now, all these points creates a healthy scenario because all of them are close to the center. And now I want you to land again. You're landing like this. Now, if you ask me, if you ask me to comment about this landing, I'll say the landing is worst. Why it is worst? Your capability is to land around the center. But now you moved away from the center. And that's why, I say this is one of your worst landing. This is one of your worst landing. I hope all of you will agree with me. Similarly, further landings are like this. Now everything, is around the center, and some of them, most of them are on the left side. And again, you are landing. And again, you are landing. And see here, these landings are perfect. You are on your target. But this landing on the right side, you are at your worst. Here, you are at your worst. But here, you are at your best. And you have made about 100 landings. But on an average, if I want to make a conclusion, I should find out, the central tendency in your landings. I measure the central tendency. If the central tendency itself is around the center line of the runway, it means, you are really doing good. You are staying focused. And see here, when I visualize this particular pattern of data, it resembles a bell shape, an inverted bell shape. This is called normal distribution. Most of the business processes, if you collect data and then visualize, it will resemble this bell shape, right? It will resemble this bell shape. This bell-shaped curve is called a normal distribution, and normally distributed curve will always, exhibit certain properties. We are going to learn it in the subsequent slides. And now, what is this line called? This is the line, the customers expect you to learn. All the passengers who are sitting in your flight would expect you to land in the center of the runway, because that gives them, the safest landing. But looking at your actual landings, the average, comes here. Whatever number of landings you made it on the right side, whatever landings you made it on the left side, more or less same. So the average falls exactly on the center. This creates a very healthy scenario. If the average is shifting to the right, it means, your tendency is, to land on the right side is more. If the average is shifting to the left, that will show that the tendency of the pilot to land the aircraft on the left side of the center line is more. But here, absolutely, there is no tendency to the right or left, and you are continuously, you stayed focused. But however, there are certain variations we observed. So average on the target creates as, healthy scenario. And now what is this particular thing? This is, one of your worst landing on the right side, the extreme output from your process on the right. Similarly, the extreme output on the left side of the process, isn't it? These represents the worst landings. We call these points as control limits. We call these points as process control limits. On the right side, it is called upper control limit. On the left side, it is called lower control limit. And now what is this line? This is the line where the runway ends. At any point of time, none of your passenger would like you landing the aircraft beyond this point, isn't it? Because if you land the aircraft beyond this point, that is going to be completely unsafe for them, right? So this is called, the maximum limit which your customer can tolerate, right? We are going to call it as specification limits. On the right side, it is upper specification limit. Similarly, on the left side, it is lower specification limit. So the customer targeted value is here, process average is here, and the upper specification limit is here, lower specification limit is here, upper control limit is here, lower control limit is here. Whenever you could see the control limits staying inside the specification limits, your process is considered capable. The pilot can now be concluded as a capable pilot because out of all landings, almost all the landings, he is able to make it in the runway. How am I making this statement? Because the extreme landings, even the worst landings are the safe landings for the customers or the safe landings for the passengers. So whenever you see the control limits falling inside the specification limit, your process is capable. Your process can be considered capable. Otherwise, your process is prone to failure. But here the chance of failure is very, very less. Hope all of you understood what I am explaining now, right? So getting the control limit inside the specification limit means you are playing the game of business very well. Always the average calculated from the process data should align with the customer target. Any business, any product, any service. We will convert the requirement into numbers, and from the process data, if the average meets the customer requirement, the customer targeted value, that's a healthy scenario, right? And variation is always, as not unpreferred in any business process, but we just cannot avoid variation. Rule of the nature, there will be variation, right? So process output shifting to the right side of the center, shifting to the left side of the center will happen, right? Shifting away from the target to the right, shifting away from the target to the left will anyway happen. We call it variation. Keep an eye on the variation and try to make sure the variation is very less. The customer provided limits are called as the specification limits. Upper specification limit, lower specification limit. Any of your product, if it goes beyond the specification limit, customer will reject your product. And that's why, the failure is considered external failure. However, the process will also have some extreme output. We call them as control limits. On the right side, it is upper control limit. On the left side, it is lower control limit. If any of your product, any output from your process goes beyond control limit, you need to understand it is an unusual event. It is an unusual event, and you must immediately try to investigate why our products are going beyond control limit. And looking at failure in this aspect is called internal failure statistically. So based on the discussion, measures of central tendency and variation, and see here, all of us could have played this game, shooting balloons, in the beach. See here, when you want to shoot a particular balloon in the center, what is most important is you should know how to hold the gun. You hold the gun in such a way that the bullet that is coming out of the gun is in perfect alignment with the center. This is what the average is also telling you. If the average is right on the target, that means, you know how to hold the gun. If you don't even know how to hold the gun, and it is difficult to hit the target, right? So average gives the first information, first clue, first indication, whether you are going to hit the target or not. And now average is sounding good. Average, holding the gun straight doesn't mean that, you have hit the balloon. No, you really have to shoot and see to that. Every time you release the bullet, it actually hits the balloon. And that's why after looking at the average, we should look at the variation, maybe standard deviation, maybe range, or maybe variance. If the variance is small, your average will speak the reality better, right? And see here, now I am actually shooting. Now it hits the balloon at the center. Again, second time I'm releasing the bullet, and again it is hitting. Third time, every time I am hitting the target perfectly. It means absolutely there is no variation. If variation is small, average will speak what is going to happen. If I release one more bullet, can you make a guess what will happen? Yes, the next bullet will also hit the target. How am I telling? Because my process average is on the target. my process standard deviation is very small. If the process standard deviation is very small, the uncertainty involved will also be reduced. If the uncertainty is error, if the error is small, whatever you conclude using the average, that will definitely happen in the real time, right? So if you want to produce quality products, you should always remember this function, right? Quality is a function of process average, process standard deviation. What is our requirement? Process average should be on the target, close to the target. If it is on the target, beautiful. And process variation should be small, right? Process variation should be small, and lower the variation, higher will be the capability, right? So hold the gun correctly and hit the target consistently. If you don't hit the target consistently, that means your process is out of control. Even though you hold the gun correctly, you are not hitting the target. That means your process is out of your control. And other thing, if you don't know how to hold the gun, it simply means your process is off center, your process is off targeted. Hope it is clear to all of you. We are going to learn the properties of normal distribution. If you look at my slide, you can see a triangle, and I have drawn a center line, isn't it? And now the center line is found to divide my triangle into two equal halves. That means the triangle is symmetrical at the center. Whatever you see on the right side of the line, the same thing you see on the left side. If the total area of the triangle is 100%, then the right side triangle occupies 50% of the area. The left side triangle occupies 50% of the area, right? So now I'm going to remove this triangle and I'm going to bring the bell-shaped curve here, right? The right side portion of the triangle is removed. Now the left side portion also removed. Now still you can see, the center line available. Now this center line, will divide your bell-shaped curve into two halves, which means the bell-shaped curve is symmetrical at the center. If the bell-shaped curve is symmetrical at the center, what will be the area of the curve to the right side of the center line? 50% area available. Hope all of you agree with me. Similarly, the left side of the center line, 50% of the area is available. And this 50%, majority of the area is available close to the center line, which is indicated by the blue color line. Hope all of you could observe that, isn't it? A major portion of the curve is available in the form of blue color, which is, near to the center line. And what percentage it is? 34.1. Whatever you observe on the right side will be applicable on the left side also, because your curve is symmetrical at the center. So another 34% here. So the blue color area is measured to be 68.27%. Hope all of you understand this. The blue color area is measured to be 68.27. Now I want to include some more portion of the curve, right? I come up to this point, right? And come up to this point. And now another 13.6% is included. This side another 13.6% is included. I want to go further. When I move away from the center, I wanted to have some measurement. How much distance I am moving, right? And for the first case, I moved by a distance equal to 1 sigma. I moved from the center by a distance equal to 1 sigma. And now the brown color area, 1 more sigma, 2 sigma. And now the green color area, 1 more sigma, 3 sigma. I moved away from the center by a distance equal to 3 sigma. Now I realize only a very, 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 very meager, small portion of the curve is available beyond green color. So I don't want to analyze beyond the green. So I would like to conclude by considering this point. What is this point? Point at a distance of 3 sigma from the center. This point I am going to consider as the extreme output from the process. Actually, no, the curve goes up to infinity. Up to infinity on the right side, up to minus infinity on the left side. It will never touch the axis. It appears as if it is touching, but actually it will never touch the x-axis, right? Always the curve will be an asymptote to the x-axis. So up to 3 sigma, the extreme output comes here. This point I am going to call it as upper control limit. You remember in the landing example, the extreme landing is called the upper control limit. Here statistically upper control limit can be located by moving away by a distance of 3 sigma from the center. This is upper control limit and this side is lower control limit. When I include all the area, up to control limit, see, there is 34%, there is 13%, there is 2%, and similarly on the left side. When I include all the blue color area, brown color area, and green color area, what percentage of the curve is covered now? 99.73% of the curve, will be covered within the control limit. That means 99.73% of the points will lie inside the curve, between the control limits. Suppose when I consider only up to 2 sigma limit, the 2 sigma limits are called warning limits. Now I am concerned about only the blue and brown color area on the right as well as left. So when I consider the 2 sigma limit, that is the warning limit, 95.45% of the area of the curve is covered. When I consider only 1 sigma limit, that is the blue color area alone, 68.27% of the area of the curve will lie within 1 sigma limit. So this is an important property of normal distribution. So if I know where is my control limit, it simply means I have understood about 99.73% of the outputs that are going to come out of my process. Because my process is normally distributed. How do I know? My process data is resembling a bell shape. So my process data is normally distributed. Whenever my process data is normally distributed, I will immediately conclude that 99.73% of the outputs that are going to come from the process will lie inside control limit, right? So I can predict about the output, if I know the control limits from my process, right? The other properties of normal distribution are the mean, mode, and median all are equal. If you calculate the mean, median, and mode, all of them will be equal or will be close to each other. If it is close to each other, it is approximately normal. If it is exactly equal, it is a perfect normal curve, right? The curve is symmetric at the center. Exactly half of the values are to the left of the center and exactly half of the values are to the right of the center. And always the total area under the curve is 1. In terms of percentage, it is 100%. In terms of probability, we say it is 1. Suppose in terms of the DPM, OPPM, you can consider the total area under the curve as 1 million. 1 million is 10 lakhs. 1 million means then the 50, half of 0.5 million will be on the right side, 0.5 million will be on the left side, right? Hope the properties are clear to all of you. Methodology. Six Sigma is a methodology to reduce defects by reducing the process variation. So what will happen? This will improve the performance on the CTQs that are going to come out from the process, right? So there are 2 methodology, DMAC, another one is DMADV. DMAC is to facelift an existing product, improve the quality of an existing product. We are trying to cure a disease. DMADV, we are developing a new product. It is a birth-giving process. We wanted to be sure that the child that is going to born is completely disease-free, isn't it? So that is DMADV, a new product development. This methodology is also known as design for Six Sigma. And now let us understand the statistical aspect of Six Sigma with an example. Imagine a company, a call taxi hiring company, right? Like Ola or Uber or something. And now what is the customer requirement here? What will be the customer requirement? As a customer, when you book a car using the app, you expect the car to arrive according to the targeted time, isn't it? The targeted time will be indicated by the app itself. Hope all of you agree with me. Imagine, let us analyze a situation where cars are expected to arrive in 20 minutes. Now, what is the challenge now? The call taxi company should ensure sufficient number of cars are available in a particular locality with properly trained drivers, with very good car condition, and with a very good mobile app, which can correctly estimate the arrival time of the car whenever a car is booked in that locality, right? And in a particular pin code, when a car is booked, the app is showing the arrival time as 20 minutes. So customer will think that car will arrive in 10 minutes. So the customer targeted arrival time is 20 minutes. Hope all of you understand my explanation. At the same time, due to some challenges on the way, isn't it? Always there will be tolerance. Your customer is ready to tolerate for a plus or minus 10 minutes. Though the app says car will arrive in 20 minutes, plus or minus 10 minutes is a tolerable limit, right? Maybe if you really wanted to delight your customer by always delivering the car within the app estimated targeted time of 20 minutes, then then we will probably redesign the process. But right now let us assume customer will tolerate plus or minus 10. So what is the upper spec here? 30 minutes. What is the lower spec here? 10 minutes. If the car arrives anytime between 10 minutes and 30 minutes, customer will be happy. Or otherwise, you can understand this manner. Whenever a customer expects the car to be within 30 minutes, it is a one-sided process. When the car doesn't arrive within 30 minutes, customer will cancel the order. If it arrives before 30 minutes, it is always accepted. So it's a one-sided process. But for our requirement, now we are going to change the requirements. Customer targeted time is 30 minutes, but we will design the process like this, 20 plus or minus 10. That means we are designing the process in a way that always the car will arrive in 20 minutes. Even in worst case, car will arrive within 30 minutes. In the best case, car will arrive in 10 minutes. Now, what is the upper spec? 30 minutes. What is the lower spec? 10 minutes. I'm going to, if every time a booking is done, if the car arrives within this specification limit, your process is considered capable, right? I'm visualizing this. Upper spec is 30 minutes, lower spec is 10 minutes. Customer targeted arrival time is 20 minutes. The total range is called specification width. Higher value minus lower value is 20 minutes is the customer tolerance. 10 on the right side, 10 on the left side, which is also called as specification width. Hope this diagram is understood. Now I want to measure my current capability. In order to measure my current capability, the past performance data, a sample of 100 data, that means 100 car deliveries, happened in that particular pin code. The data is picked up. Now I have arrival time of 100, car deliveries. So 100 data available. With 100 data, I calculate average. That average is X bar. X bar is calculated to be 20. What is the customer targeted value? Customer targeted arrival time, that is also 20. What is the average of your data? That is also 20. It simply means you are holding the gun correctly. It simply means you have captured the customer requirement and designed the process in line with the customer requirement. The process is designed carefully and correctly. And that is what your X bar is telling. Now you can actually expect your car to reach the customer place in 20 minutes, which is, this is called voice of the process. From the process, I collected data, calculated the average, and that average is on the target. Though average is on target, it doesn't mean that every time the car is arriving in exactly 20 minutes. No, plus or minus. So in order to know that uncertainty, I measure the standard deviation using the 100 data. You just now we learned the formula, right? I'll use the formula and standard deviation is found to be 3.33. And now locate your control limit. What is the formula for control limit? Process average plus 3 sigma. Sigma 3.33 means 3 sigma will be 10. So 20 plus 3 sigma will give you 30. This is upper control limit. Similarly, lower control limit is 10 because X bar minus 3 sigma. 20 minus 10 will be 10. Now find out the process width using this formula. Upper control limit minus lower control limit. That is also 20. Specification width is 20. Process width also 20. Now I want to know the capability of my process. So I'm going to overlap the control limit with respect to the specification limit. Let me overlap in the second slide. Now I have overlap. See here, specification width is 20 minutes. Process width also 20 minutes. It resembles like, the car size and parking area size are almost same. The process looks capable. The process looks capable. See here, process is just capable. Right now it is capable. The car size is exactly equal to the parking area size. But when I park multiple times, when I shift from the center slightly, what will happen? My car will get damaged. My idea was not that great, but it looks great as of now. So this process can be considered as a mere capable process or a just capable process. And the process also resembles a normal distribution. Looking at the data, if you plot a histogram, you will immediately come to know, right? It resembles a normal distribution. And according to normal distribution, 99.73% of your data points will lie inside control limit. 99.73% of the car deliveries will definitely lie inside control limit. Since control limit overlap with the specification limit, 99.73% of your data points will also lie within specification limit. If there are 1,000 deliveries happening in a day, 1,000 bookings happening in a day, 99.73% of the bookings, your car will arrive between 10 minutes and 30 minutes. How am I making this statement? My sample study, I have done it systematically. Without any error, I calculated average, I calculated standard deviation. Now my business is running like this, 1,000 bookings a day. 997 bookings, my car will reach the customer place between 10 minutes and 30 minutes. Maybe three bookings, my car might reach beyond the 10 and 30 minutes. So beyond 30, my customer is going to cancel the order. So if you ask me whether I'm happy with the business, yes, today I'm happy. But the only risk here is the situation is resembling like parking area and car size almost same. Any small mistake will amplify the failure. Right now the failure is very less, but a small mistake, suppose 10 cars are not coming tomorrow, or the drivers are absent tomorrow, few drivers, these are all quite possible. As a result, what will happen? Immediately the number of failures will be more on the particular day. If you are also concerned about these kind of long-term requirements of the business, you should improvise the process further. As of now, if you ask me what is the sigma level of the process, you need to measure the distance of the process center from the nearest specification limit. The nearest specification limit is this, and process center is this. How much is the distance? You can see. How many sigmas are here? 3 sigmas are here. So this process is called a 3 sigma process. A 3 sigma process will assure an yield of 99.73%. How do I say this? Property of normal distribution, rule of probability, right? So 99.73% of the time, my car will arrive customer place within the specified timelines, isn't it? And this process is called 3 sigma process. This process is called 3 sigma process, just capable process. However, this capability is true only for the short term. In long term, problems can happen using different ways. Like some challenges will come and play. The variation can increase over long term. So as a result, the number of failures might be more. If the variation increases, what will happen? If the variation increases, control limit will get stretched, isn't it? Because control limit is decided based on the process center as well as the value of the standard deviation. If the variation increases, control limit will get stretched. The spread of the process will increase. As the spread of the process increases, control limit will go beyond specification limit, and all your conclusion will go wrong. And that is why it is important to control the variation. So one way I told you how process can go wrong. Variation will increase. Another way is the entire process might get shifted to the right or shifted to the left because of wear and tear of the equipment, because of the absenteeism of the operators, or maybe because of some changes that are possible in any business. So the entire process might get shifted. Let me show you the shifting of the process, and see here. And before going to the shifting of the process, I'm going to give a nickname to the process. If you look at the curve nature, it looks like head of the elephant. So I'm going to call this process as an elephant process. Now you need to understand, you have put an elephant inside a small room. You have put your process within the specification limit, and it is a tight situation. Tight situation means If the process deteriorates, if the process is shifting or deviating slightly, then immediately failures will start happening, right? An elephant cannot stand in a small room for a longer time. Even the small movement of the elephant will damage your walls of the room. So that's why, this process, is called as just capable process. So in the long term, the damages will be more. And see here, now, as of now, the damage is happening or the failures are happening only here. This is why we say, the percentage of failure is very small, 0.27. But this is true only in short term. In long term, what happened? Your entire process can shift either to the right or to the left. I'm imagining, only the right side because the left side is safe. Here, this is a one-sided process. When the process shifting to the right, can you now understand your control limit has moved to the right side? See here, your control limit has moved to the right side. Now look at the gap here beyond the specification limit. No, the rejection is not only on the red color area, but also on this white color area. Your rejection has now increased. What you thought as 0.27 is actually, has now actually become about 8 to 10%, or it can be more than that, right? Depending on the values of the control limit and specification limit. So a process which is capable in short term becomes incapable in long term. Why? Because in the long term, the variation can increase. Because in a long term, the entire process can get shifted to the right or left. And that is why we need capability higher than 3 sigma. Because, even 10% rejection, companies definitely, may not be willing to tolerate. So we have to improve the process. There is a clear need for, to improve the process beyond 3 sigma capability. And now for the same process, same call center, I have improved the process. How did I improve the process? I have tied up with more number of cars. I have trained all my drivers, isn't it? I have given a GPS system in the car. I have introduced OTP mechanism. There are several improvements I have made. As a result, again, process average is on the target. But look at my standard deviation now. Now I improved it drastically. Earlier it was 3.33. Now it has become 1.66. Now the revised control limit, upper control limit is 25. The lower control limit is 15. Now what happened? Always every time my customer is booking a car, now I am able to provide the car between 15 minutes and 25 minutes as against my earlier behavior of between 10 minutes and 30 minutes. Now I minimized the variation. I am not even sending my car too early. I am not sending my car too late. And my customer specification is up to 30 minutes. But I always make sure all the time my car reaches the customer place within 25 minutes. So now I am very sure that between 15 minutes and 25 minutes, 99.73% of the deliveries will happen. If within control limit, this much percentage can happen, what will be the percentage between specification limits? More than 99.73, isn't it? That means my process has become much more capable now. If you actually look at the size of the process, my process has now become doubly capable. How do I say doubly capable? Look at the specification width, 20. Look at the process width, just 10. Imagine you give your child 20 rupees pocket money, but your child is spending only 10 rupees and put the remaining 10 minutes in savings. And definitely this savings will help your child in a challenging scenario. That is what you are doing in the business also. Customer has given you a wider tolerance. You are using only half of the tolerance. Even if something goes wrong, the remaining tolerance which you saved will definitely save you. And that's how you make your process 100% failure free, close to 100% failure free. And definitely all your products and services will be defect free in the hands of the customer, right? Even if your process shift, or drift, the rejections will still be very, very lower. If you ask me the sigma level of the process, look here, the process center is here, specification limit is here. What will be the distance between process center and specification limit? There are 6 sigmas you can see, because control limit stays at 3 sigma, and the entire gap is actually how much it is. Yeah, 10 on the right side, and up to this is 5. So this will be remaining 5. That means there are 6 sigmas between process center and the nearest spec. This process is called 6 sigma process. This process is called 6 sigma process. That means the capability is doubled. Under such situation, even if your process, we are going to call this process as giraffe process. Why the name giraffe? When you push the control limit, when you reduce the variation, control, you can see control limit getting pushed inside. When the control limit pushed inside, the curve will become narrower. The curve will not only become narrower, it will also become taller in the center. And that's why, just to remember the concept, I'm saying that you converted the elephant into a giraffe. So seeing the narrower curve, seeing a taller curve means your process capability has become higher and higher. And now see here, my process is shifting. Statistically, it is estimated that the process will shift by an amount equal to 1.5 sigma. So this process, when it shifts, see here, look at the position of the control limit. The control limit move by an amount equal to 1.5 sigma. In whatever capability you see in the short term, will be higher than the long-term capability. That means the long-term capability will be lower than the short-term capability. Why it is getting lowered? The control limit will shift by an amount equal to 1.5 sigma. But even after the shifting of the control limit, still you have some more tolerance. Even if your car gets delivered beyond the control limit, it is only an internal failure. It becomes objectionable only for your business. Customer will still accept, right? But however, every time a point is going beyond control limit, we will consider that as a special cause. We'll react to it. We'll question ourselves, how come a delivery can happen beyond control limit? So what went wrong? We'll immediately correct our process, and thereby we can prevent the future failures, right? And this process is called the Six Sigma process. And now the success rate will be definitely higher than 99.73. It is 99.999%. 99.999%. And look here, the failure is happening in this manner. Even though the failure is represented by red color, only a small portion of the red color area will get noticed by the customer. And that's how Six Sigma is assuring you a result of close to 100%. If at all there are any failures, that will be limited to just 3.4 dpmo. What is that 3.4 dpmo? The small portion of the red color area extending beyond the specification limit. This is 3.4 dpmo. This is how Six Sigma capability delivers results close to 100%. Hi, hello. Hope you have gone through the statistical modules and enjoyed them very well. And most importantly, I understand you have clearly understood the practical meaning of Six Sigma, which means you are all set to understand the DMAIC methodology. In the upcoming videos, upcoming lessons, I'll be taking you through the DMAIC phase by phase. Define, measure, analyze, improve and control. As well as within every phase, I will take you through step by step, tool by tool. That means your learning is going to be a walk in the park. So enjoy all the upcoming lessons. Thank you for watching.